Welcome to another TOEFL listening practice video. In this video, you will listen to a lecture, answer some questions about it, review the correct answers and explanations. Don't forget to subscribe for more TOEFL listening practice.
Good morning, everyone. Today, we're going to discuss an important environmental issue: the effects of pesticides on pollinators, with a particular focus on bees. Bees are one of the most critical pollinators in the world. It's estimated that 1/3 of the food we consume depends on pollinators like bees. They're responsible for pollinating a wide variety of crops, everything from almonds and apples to cucumbers and strawberries. Without bees, global food production would face severe challenges. Unfortunately, bee populations have been declining, and one of the major contributing factors is the use of pesticides in agriculture. Let's first clarify what pesticides are. Pesticides are chemical substances that are used to kill or control pests, such as insects, weeds, or fungi that can harm crops. While pesticides play a vital role in maintaining crop health and ensuring food production, they don't just affect harmful insects. Many pesticides also impact non-target species, including beneficial pollinators like bees. One class of pesticides that has garnered significant attention in this regard is called neonicotinoids. Neonicotinoids, or neonics for short, are a widely used group of insecticides. They work by targeting the nervous systems of insects, causing paralysis and death. What makes neonics particularly harmful to bees is that they can remain in the environment for long periods, even after they've been applied to crops. Neonics can be absorbed into the plant, meaning that even the nectar and pollen bees consume can contain these chemicals. Now, let's talk about how these pesticides affect bees. The primary concern isn't necessarily that pesticides kill bees outright, though that can happen in extreme cases. Instead, sublethal exposure, meaning exposure to low, non-lethal doses, can impair bees' behavior and health. For instance, bees exposed to neonicotinoids can experience a loss of navigational ability. This makes it difficult for them to find their way back to their hives. Imagine a bee venturing out to gather nectar, but being unable to return because its sense of direction is disrupted. Over time, this leads to fewer bees in the colony, which weakens the entire hive. Additionally, pesticides can affect bees' ability to reproduce. Queen bees may lay fewer eggs, and the overall lifespan of worker bees can be shortened. These reproductive issues compound the problem, as fewer bees are born to replace those lost to pesticide exposure or other environmental threats. Another issue is that exposure to pesticides can weaken bees' immune systems, making them more susceptible to diseases and parasites. One such parasite, the Varroa mite, has devastated bee populations globally. When combined with the stress of pesticide exposure, bees are much less able to defend against these threats. Given all these negative effects, you might be wondering what's being done to address this issue. In recent years, many countries and regions have started to take action. For instance, the European Union has banned the use of certain neonicotinoids on crops that attract bees. This was a major step in protecting bee populations, but it's not without controversy. Many farmers rely on these pesticides to protect their crops from pests, and alternative methods can be more expensive or less effective. In the United States, regulations have been slower to change, though several states have introduced measures to limit pesticide use. At the same time, scientists and environmental groups are advocating for more sustainable agricultural practices. Integrated pest management, or IPM, is one such approach. IPM emphasizes the use of biological controls, like introducing natural predators to deal with pests, rather than relying solely on chemical pesticides. By adopting practices like IPM, farmers can reduce the need for harmful pesticides while still protecting their crops. Another promising area of research involves breeding bees that are more resistant to pesticides. Some scientists are working to develop bee populations that can better tolerate low levels of pesticides without suffering as many harmful effects. While this doesn't solve the problem entirely, it could provide a short-term solution as we work toward more comprehensive changes in pesticide use. To conclude, the effects of pesticides on pollinators like bees are a serious concern, not just for the environment but for global food production. As bee populations decline, we face the potential for reduced crop yields and rising food costs. It's crucial that we find a balance between protecting our crops from pests and preserving the health of vital pollinators. Through a combination of regulation, scientific research, and sustainable farming practices, we can help ensure that bees continue to thrive and support our ecosystems. Thank you. And let's now open the floor to any questions you may have on this topic. Question 1. What is the main environmental problem discussed in the lecture? Question 2. What makes neonicotinoids particularly dangerous for bees? Question 3. Why does the speaker mention that bees exposed to pesticides have trouble returning to their hives? Question 4. According to the lecture, how do pesticides affect the reproductive abilities of bees? Question 5. What can be inferred about the relationship between pesticides and diseases affecting bees? Question 6. How does integrated pest management, IPM, help reduce the need for pesticides in farming?